I'm low. I'm low. I'm low. Yes, it is I. It is I am early-ish, kinda early. Um, no one is here, but it does hurt. Hello, Saribots. One of the greatest things in sliced bread. So, yes. What is Animal doing? Let's do a little bit of a recap here at Play. Um, whoops. So what we want is here. Yeah, I was gonna try and do the tube thing, but don't work. It does not work on my machine. So there are, and this is just an artifact of this kind of pattern. And that is mainly because the yeah, I mean, I could do. I don't know if I want the top and the bottom to be mirrored, because the ceiling and the floor being exact mirrors, I don't know if I like that. Alright. Also, I'm blinking now. Cool. My eyes are getting a little dry. So I blink. That's cool. So we have full edge detection. Which is cool. I could subtract and do, like, there's a lot of things. Okay. That is very concerning. Hold on. Yeah, 1 second. Yeah. Now I have a plastic bag full of ice under my computer, and that should help with the issue of overheating in due time. Seems like one of them is very rough, so yeah. It's a little bad, but I'm sure it'll be fine. I think it would be better if I did it like this, I think, is the better way of doing it. Trying to just figure out exactly where this, oh, yeah, that's immediately a lot better. Okay, cool. So, I don't know if I like the, yeah, I don't know if I like that or not. So another way of doing this is, what is the, go into the screen, flip times that cell for y times x plus 9, flip times 19, flip up. So that is actually doing the things the way that I expect it to. So the main thing that we want to do is we want to also figure out if the whatchamacallit, we want to see if the what is it? If we're looking at the ceiling or if we're looking at the floor. Because we could do something a little bit different depending on each one, right? Another thing that we could do is sink it down and then multiply. Sink everything down and then multiply and then camp again. Which will kind of widen these black parts more. But I don't know if I want to do that. Yeah, I don't know. And it is nicely lined up, so I guess I'll just keep it as is. As it is for now, because it's fine. Yeah. Because like this is looking pretty good. So it really just depends on where we want to go from here. It just depends on what kind of situation we want to put ourselves in. Um, so there's a few different ways of handling the fog. So for one, I can do fog. Um, I can handle fog by, I think the distance. Oh, right. Okay. UVT is. I mean, I could just say UVT. I think I'm passing in the UVT into the floor text. Oh, that's just a UV. Interesting. Um, right, right. Okay. That does make a lot of sense because what we could do is we can, um, yeah, because we have the edge stuff, the get color, floor text, floor text. Oh, I'm just flipping the whole damn thing. Interesting. Okay. Uh, Um, hmm. Well, what kind of difference do I need though? Right? Because like I don't know what kind of I don't know what kind of hmm. So what kind of difference am I going to do? So okay. Floor, ceiling, cell, UVT, X, Y. I mean, I could literally just do that, and then the floor texture, I can just pass in the instead of a vec2, I can do a vec3. And then I can make this a UVT, and then I do UVT.xy times 4, and then I can say, yeah, because it doesn't matter, right? Because the ceilings are going to be different. The ceilings are going to be different because the ceilings are evaluated separately. Because it's the inside of the cell. When you hit the ceilings, it's the inside of the cell, not the outside of the cell. It's the inside of the cell. All right. Because this is a tile set, not a voxel set. There is a big difference. We will at some point when I get into Stortham. I mean, I might make it similar to like Minecraft. Oh, I mean, I might choose a finish name if I wanted to, if I really want to. I'd gone for Swedish for Storkum. I might go for Finnish for yeah, for the rebuild for remake. Only time will tell. Only time will tell. Only time can tell. So we have that, and then for UVT.Z. Okay. I can do UVZ, yeah, UVT.Z. Uh, yeah, we'll see how well this works. Fuck. God damn it. Where? Nande. There we go. Oh, that's not good. Ah, right. There we go. So now, these are distinctly separate. Now these are all distinctly different. The top and the bottom are different. There does appear to be some similarities in a lot of cases, maybe, but I mean, they are distinct, right? Top and the bottom are distinctly separate patterns. So it just depends on whatever it is you want to do. They will fully formulate however it is you want. So we have success, my friends. Yes, 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 yes. Yeah. Yeah. I mean, it's just it formulates everything the way that you want it. So it's fine. This is all very Gucci. It's all very good. I don't know how I'm going to do certain other things, like the fact that this is like black and white, right? Like this is all grayscale. So the next step is, so we have a separated, what is it that we have? We have separated, yeah, I'm a little bit sad that GitLab does not do hosting, executable hosting, which is something that I don't fucking like at all. That needs to be a thing. That's one of the biggest parts of So one of the biggest detractors to GitHub is that it has, you know, GitHub is has hosting. It hosts executables. GitLab does not. And I use GitGood, which is a GitLab host, right? Because yeah, GitLab is not like a full. It's not like a fully separate. Like it's not a fully self-contained system. It's it's a it's I don't know how to explain it. Yeah, it's just a little bit different, right? So let's see. Next, I think I want to mess with the what's gonna be the biggest impact? The fog, the distance, fog distance. So we have that. Cool. Next is we want the fog distance. To get fog. 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 There we go. So we have this. Now interesting. The length of what is it? R dire. Let's find out. Nande. What? That's not correct. Fog. Oh shit. Yeah, that no longer does the weird shit on the corners, which is good. So we do have that, which means that now, since we have circular radial, true radial distance calculation, which this just looks nicer, looks a lot better, right? You know, we have normalized systems now. Since we have a full normalized system, we can do what? We can start messing around with the fog values, right? With the fog calculation. And that's just something that we want to do, right? We want to recalculate the fog systems and see. That's gonna be like so how do I go before? Ah, that's how. Okay, so this is that, right? So let's say let's do in underscore D, right? So that we can have like a temp float D is equal to underscore D, right? We can have a float in here, and then we can say return D. Return D, right? So D is equal to 1.0 divided by what is it? D squared plus 1. Now this is right. We have the this is the lighting. This is the torch light. This is the torch light one, which is really moody. I do like how moody this is. And we can modify this to be a little bit less. Okay. Because we can this is the torch light. Oh, right. Plus 1 divided by I don't think this is working. Oh. Alright. So, so D divide equals. Alright, hold on. Okay. Now, this shoots it out way further. Right? This is way brighter. We could do. This is a little bit moodier, right? But still brighter, right? This is brightness 9,000, right? So this will allow for much moodier. Like I like the moodiness of it. And all that I'm doing is I'm just changing the shape of the curve, right? I love the torchlight. I like torchlight. I like torchlight fog. Torchlight fog is just, it feels the most natural. And what I mean by torchlight is that it's 1 divided by distance squared. Asterisk, kind of, sort of. I do add the 1, and that is so that as there is no, like, there's no overblow, right? So that it always maintains a sensible, um, a sensible level, right? Um, yeah. So that like the total energy is always like, you know, basically the total energy is conserved. Um, so yeah. I mean, I wouldn't mind like sitting down and running some other numbers and stuff. Interesting. That looks so wrong. But that is correct. Okay. Interesting. Yeah, so yeah. So we have the torchlight. Rather than linear, we have torchlight. The torchlight fog, which is a lot less abrupt than the regular fog, right? This still allows you to have like some sense of depth and, you know, moodiness. Things are much darker overall, but things are also like strictly bright, which means that you can see things a lot better, even though things are super moody and dim, subdued, muted. It gives it a very yeah. So we have that. Now we could do 1.0 minus, right? Like, oh god, that's so fucking bright, dog. Like, that's so bright. That shit sucks. There's a lot at hand here, and yeah. There's just a lot of things you could do with it, right? So, you know, yeah, there's like the inverse fog, things like that, right? I do really want to do, I think the vaporwave, the vaporwave one is going to be different, because like I'm still doing this all in black and white. I'm still going to maintain black and white, because go fuck yourself, basically, is what it boils down to. I don't think there's like multi-shader stuff, right? Being able to like import shaders and things like that. I don't think that's a thing you can do. I'll have to look into it. Largely, from what I understand, that it all boils into the pre-compiler, right? That is That's close to unfortunate. Well, welcome to procedural generation. Uh-huh, interesting. Now, there is no guarantee that there are no, yeah, like there's, like, yeah. There's no guarantee that it's, oh, hello, hello. I am super terrible. Hi. Hello. Hello, unknown coop. How is AMR? How you doing this morning? And welcome in, welcome in. I don't think I've seen you. I don't think I've seen you. Then again, my memory's dog shit, so, you know. It is what it is. But yeah, this is my project. I don't know if I like that distance or if I want to bring it in more. I can bring that in by quite a bit. No, fair, fair, fair. That's fair. I definitely feel it. This is a little bit nicer. This is definitely a lot moody. Bring it in more. I could do cubic. That will flatten the curve out. I could do a true bell curve. I don't know. Because like this, I feel like this has a really good, oh. I feel like this has a really good, look and feel to it. Oh, I also want to, I want to have variatic, bricks. Right? I feel like the bricks are a little bit too regular. And if I could offset the length and stuff of them on like a per brick basis, that would be super sweet. So I think all that I need to do is, how would I do that? Because if I could do variatic bricks instead of them being so strict, then it would look really, really good, right? Hmm. So How do I want to do it? Yeah. So, hello. Hello. How do I do variadic bricks? Do I want to do variadic bricks? Because if I could change like the length of the brick. Well, I mean, because basically what I'd be doing is, let's take a look at what do I have access to? And I don't think I have a brick rate. I don't think I have a brick ID, right? Because the floor UV dot Y. Oh, this is okay. IVEC2 BID is equal to 4 UV. Okay. And then here, I just do bid.y, right? And then what we could do here, because we have like the full, brick stuff. Then because we want to have, we have the brick ID, we have the cell. I don't have the cell. I only have the brick ID. Which means each individual cell is going to be the fucking same, and I don't like that. So we do want to pass in IVEC2 cell. In IVEC2 cell, let's go back down into effects and do up into here. Yeah, here we have the BID. So we have the floor, we have the cell. We want to I mean, we don't want to move it by a bunch, right? We just want to oh wait, shit. Where's yeah, okay, yeah. The brick shift. And then we do uv.x plus the shift minus, yeah, the shift minus a half. We're just gonna have shift, right? So float shift is equal b shift is equal to 0.0. Right. Here So B shift. B shift is equal to fractional component of the tangent of the cell.x times 7.9 bunch of garbage, right? B shift is equal to fractional component of the tangent of B shift plus cell.y times that nonsense. B shift is equal to the fractional component of the tangent of B shift plus bid dot x times that's B shift is equal to fractional component of the tangent of B shift plus bid dot y times that. And then that should be fuck. 155. Ah. Alt text. Did I not do IVEC2 cell? Wall text, okay. There we go. There we go. So, this is really fucked up. How fucked up is fucked up? Super fucked up. So, that's way too much. Alright. So, B shift is equal to B shift minus equals 0.5. B shift times equals 0. I'm thinking I'm doing something wrong. So, what is it that I'm doing wrong? What happens if I do that? Interesting. More of a variety of brick stuff, right? So it kind of breaks things right on the boundaries, though. Right? Oh, but not necessarily. What happens if instead of doing... Okay, so that's... There's still some breakpoints. Right. That's cool. So, I don't know how I feel about these situations here, right? Is these situations, like, what is going on here? Nonde. Like, why? Why is that a thing? Why is that so broken? Right? And why is it in the middle of the tile as well? Um, right? And why is this one so well behaved? Oh, wait, hold on. What if I do this, and then I do uv.x times equals 1.0 plus still all really fucked up. I don't know. I mean, I also don't know if it's going to be worth it. And relax while you code basic RPG components. Meanwhile, you get to use things like actual math equations and complex systems. You can stare at a wall for 30 minutes. I mean, I mean, you're not wrong. Nonde. Why the fuck is this wrong? Oh. I actually think if I do, because I think what I could do is I could do um do. Are you using like a RPG maker or what are you working in? If you don't mind me asking. So, bid.y. I think this is probably going to do a better job. Ooh, almost. Interesting. This part still gets really fucked up. Interesting. Because I want it. Because I want each one to be offset. Right? Like, I want each one to be a different thing. So, but. Okay. So, there needs to be, the fractional. Yeah, the UV equals frac UV. So, Nonde. Let's do. Um. Let's go back down here and then do color equals test and then shit. Okay. Oh, holy shit. Okay, so that is getting very messed up there. That is good to know. That is getting super messed up there. Godot? It doesn't follow the type of RPG that RPG Maker works in. Yeah. I mean, I get you. Godot is pretty cool. I like Godot. As an engine. So why is this getting all how fucked up is fucked up? Oh, also, why am I doing 1? I should be doing 0. So, the main thing that we want to... Where is test? Factory... Interesting. So these walls are getting very fuzzy. That's good to know. Because that is on the Z side. Oh, wait, hold on. Nonde. In the... No, it's the wall texture. So why? Why is it only working on the XY? And why is it being split vertically there? Why are we getting those ghost actions? And why is we having that? Weird. Okay. Why? Why is it only here? Why is this the only one? Under. Why? ¿Por qué? Oh, it's because it's doing one and then the other. That's why. Okay. That actually does make yeah. No, that actually does make sense. It's because it's not masking it out. It's just doing whatever the last one is. So since the last one is the y-axis. That's why it's okay. That's why it's only doing it to the y-axis. That actually makes sense. That is working properly. Okay. So with that, okay. So we want to what happens when back 3. Website stuff, currently shopping around, front-end frameworks. Ooh. Okay. Interesting. Interesting. What if? Hold up. B shift minus equals 0.5. UV dot x plus equals B shift 0.5. And then we can say getting closer. Getting closer. And that is when everything goes to shit. Goes to hell in a handbasket. Why? Doesn't do anything. Um, Still doesn't do anything. What? Nande? What is... Okay, what's happening? What happens here? Oh yeah, it's super crazy. Okay. Neat. Not what we want. We want plus equals. Okay. Interesting. Okay. We have... Oh shit. That is not good. Um, I genuinely believe that my computer's fan is broken. That's fucking cool. Means I think I'm gonna have to end up using ice to cool it down. Because 95C is way too fucking hot. Okay. How important is... Oh... I cannot have... Okay. I'm starting to understand it now. Okay, I get it. So, the bricks cannot be... Interesting. So how do I normalize the gradients? Hmm. Interesting. Hmm. So what would be... Mm-hmm. Okay. Gotcha. Okay. Right. Because there is a... The... So... Okay. Um... Okay. So let's do... Let's rethink. Let's rethink this entire thing. Let's rethink this entire fucking thing. Let's delete that. Delete that. Let's delete that. Let's delete that. So I'm gonna have to effectively. Hello? Yo. Helps if I actually do the right thing, doesn't it? So let's delete that. Um, okay. So, we have a white wall. Okay. Okay. From the bottom to the top. From the top down. Alright. So... Okay. Let's also... just do that for now as well. So, it's gonna start at 0 and it's gonna go up. Okay. One, two, three. Nande. Ah. Okay. Okay. So this is 8 per. 8 per cell. Alright. Well, 8 per unit. Um. So. What we want to do is have. I mean, we could do that. Alright. Because if we have the if we have so if we have those, then we take a look at the x gradient. Because we want it to be mostly consistent, right? We want it to be mostly consistent. We want the ID to be the floor IVEC2 BID BID.y is equal to floor UV.y. God fuck damn it. Okay. Is equal to val fractional, well, yeah, fractional component of BID.y divided by yep. That is correct. Good. Then we also want to have now the BID of X. Because if we could do the X and the Y, right? And then what we end up doing is, depending on the brick ID, So, depending on the brick ID, how do we do? So now we need to split it up into split it horizontal. if we split horizontal, then what? We split horizontal to do, and also in what way, right? Because in all actuality, what we want is for each of these strips. In each strip, we want to cleanly split. And that is where shit gets weird. Because, so I will show you why. Let's go into Drawy. Things are gonna get really weird. Things are gonna get very difficult. And the reason for that is, so whenever we want to have no, well, actually that's not gonna help. Each of these is basically each of these is a different integer, right? And basically what we can do is we can have, say, hey, we just do, you know, if we want to change the width of the brick, we just change the slope of this, right? I mean, that's fine, right? That means, you know, we have a brick here, we have a brick here, we have a brick here, right? You know, that's fine and dandy if we want, you know, the same size bricks. But we don't. We don't want the same size bricks. What we want is we want to have bricks of varying lengths. So we could have a brick like that, we would have a brick like that, and, you know, a brick like that, right? So in each of these will have, you know, their own size accordingly. So how do we set this? Right. How do we mask out? Because the main thing is that we want to have, we want to match it up to here, right? And all that we know is what, like, how do we, because this is the kind of thing that we want, and we want to be able to match it up perfectly. So how? Technically speaking, technically speaking, we could completely and utterly split it up so that, you know, we have something like this. Alright. We could split it up like that. We could... But the issue is the edge boundaries, right? Because what we want, you know, we have the edge boundaries, but what we want is we want to have something... Is that not transparent? That is not transparent. The GIF has no transparency. Oh, I'm gonna have to change that. I'm gonna have to look into that. I don't like that. So I guess I'm a solid black fox then. That kind of sucks. I don't think I like that. I'm gonna have to do something about that. I'm gonna have to look into that. I guess the GIF doesn't have... What? But it should have... I'm gonna have to... Alright, so... Because we need to have... So, the BIDX, the B to the I to the D to the X, XID, needs to be. Because, like, it can be modified, right? Because it can be, like, shifted over and what have you, based off of the Y value. And like it can have like a relative factor to it. The problem is we don't have a way to like mask out anything. Like I don't have a way to mask it out. I don't have a way to like I can't mask it out. I can't have it's The issue is the variadic. Mm. Okay. Okay. So, um, the another way of doing things, right, is that I can have regular spots, right, and then from here, I can have varying degrees of these things, right? Um, Now we do kind of run into a problem. We do kind of run into a problem. Um, because of situations like this, right? Like where, because like this is fine. Right? This is good. We have we have the result that we want here. Um, but here we don't, because we would have to find where this hits. Right? Um, and not to mention, we would also have to, because we'd have these sites, right? We could do, right? We'd have these sites. We'd have these sites, and we would look at the, we would find where we are, the one to the left and the one to the right. Right. So if we can split those up into those regions, and then we say within this brick we have a okay, so before I was having the edges be on the edges, right? Now I can have the brick be like this, and then I can have it be in the middle, because then I can split it off to one side or the other side, and it doesn't matter. Which means that instead of from the edges, we go from the middle. Which means I can still do multiply by that divided by 2. And then I can plus minus alright. Because like I still want the same gradient. Mm-hmm. And I do the vertical gradient based off of that. Okay. Because it's very easy to find out where Okay, so we shift everything over depending on that. So we can offset it by a half. Then we well, I mean we could say the full set is that. We add whatever the fuck. Because we don't need to do well, I mean we could do X's X gonna give it to me. I need to get something real quick. I need to get something to nom on, actually. Real quick. So I will be back with some Foxo kibble, with some Fox kibbles. Ow! No. Fuck. Ow. Hmm. Yeah. Wait, what the hell? What? It is. When did that happen? It's not inverted for the other one, is it? It's not a bug, it's a feature. Okay. Oh, just I'm just getting up to. Oh, I want to get some more food, but that also takes effort, and I don't want to effort. Mm. Yeah, I'm really not happy with my computer overheating. It's really bad. I feel like there's like literally no airflow. Well, that's great. Ah, could do. Uh, mm. Ooh. Oh. Hmm. That almost tastes alcoholic. What the fuck? It smells mildly alcoholic too. feel about that. Alright. Well, I guess the bug report. Alright. Let's get back to work here. So the uv.x is going to be x times row num rows plus or maybe even minus. Oh, fucking. God damn, why am I so fucking cold? I want blankie. I want my blankie. Oh. Oh. Okay. uv.x. I'm going to start it off by just saying uv.x is times equals num rows, which actually means I can do that. So uv.x plus equals bid.y. I mean, val equals uv.x divided by 8.0. Alright. Okay, cool, that's correct. Alright. So we want to get that step in there. Okay. Now, what we do is we have uv.x times equals 2.0. Right. God fuck damn it. Okay. No. Divide, let's do times equals 0.5. Okay. Is equal to fract uv.x. Perfect. Okay. So now that we have this, good. So now we have a system. Oh, fuck. What about the bid Y, bid X is BID, okay. BID.x is equal to int uv.x. Right. Test is equal to vec2 BID divided by 8.0. Right. And then all the way down at the bottom, $163. Helps by actually, okay. So that is correct. That is correct. That is correct. Yep. That is all correct. That is looking good. Welcome to the pea soup. Alright. Welcome to pea soup. It all looks like shit. Welcome to that. But that is correct. Oh. Yeah. So now we have the brick ID. We have the UVs. Now we want to have the brick UV. vec2 brick UV is equal to the fractional component of UV then we want to change how each of the components operate. Right? We want to change how each of the components operate. So, for one, I don't know if I like the blink intervals for my blink. Seems a little much. Seems too frequent. I don't know. I'll fucking tweak about it. I shall tweak it another time. Because I want it to do a few times per minute. Right? Like, what is the average time between blinks? And, like, the standard deviation, and then I just do that. I don't know. I'll figure it out. But anyway, so we have the, and I also know that the average blink time is 100 milliseconds, and I'm doing it at 250 milliseconds, so these are long blinks, but, like, it's fine. I don't mind long blinks because I'm also streaming at 10 frames per second, so fuck it. I don't give a shit. So, now we have a BEID. We have a BUV, which is the fractional component of the UV. We also have the ID, which is fine. So we've split up the brick information depending on the ID and the UV. Cool. Right. So we have those. Yeah. Goes down like that, and it goes up like that. Gucci, Gucci, Gucci. Gucci Poochie. How about sell? Height. Yeah, there we go. That's gonna be better. That's gonna be way better. This will be less likely to do weird shit. Perfect. So, let's see. Okay. Do 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 do. Okay. Above, so we have the brick UV. Now we want to multiply the brick UV by 2, subtract 1, get the absolute value. Right? And then do a similar thing for, yeah, so BUV dot X is equal to BUV dot, minus, times equals 2.0 above dot X, minus equals 1.0. Val equals above dot X. Let's find out. Yeah. Yeah. Absolute, above dot X equals, well, I mean, so above dot Y minus equals 0.5. Right. Above equals absolute value above. Right. Yeah. So this is what we want. Oh, right. But what we really want is we want to, before we start doing all that stuff, we want to interject, right? Val is equal to the, minimum of above dot X. Above dot. Yeah, that is correct. And that also, this is literally exactly what we had before. So I did a bunch of work to do basically fuck all nothing. Welcome to it. Right. So yeah. So when we do the minus times 2 minus 1.0, here, what we want to do is we want to make a shift, the brick shift. We do the brick shift, float B shift is equal to the 0.0. At the very end, we do BUV dots. Oh wait, yeah, here we go. float b shift is equal to 0, 0.0. Helps if I have a ending line. Above dot x plus equals b shift. Absolute value above. Alright. So nothing should change. Good, 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 good. Gucci gang, Gucci gang, Gucci gang, Gucci gang. Let's do 1. And here we have a bit of a shift-a-rooney dooney. That's what we want to see. Alright. So yeah, that's 1. Oh damn, that's like yeah, that's like really tiny. So I could do so these shifts are like really small, right? Yeah, here we have that, which is fine, I'm guessing, I guess, right? Cool. Let's see. Do. So let's see here. Yeah, because we can do 0. B shift equals the fractional component well, B shift equals fractional component of tangent of cell.x times alright. B shift equals fract And bid bid.x. Um, mhm, mhm. And this is a lot better. There's still a few little hunky dories, but that is fine. Pull that. And everything is fixed. We have completely chaotic randomized systems. A few of them are a little bit off. That's fine. B shift times that. Right. 0.75. So this way it just gives it a little bit more variation without the issues are right there at the edges, right? Still have a little bit of an edge case. So one way that we can fix that is well, there's a few different ways that we could do it. So it would be nice if every single one is like unique and stuff, but that would mean continuity along the X and Y planes. Because the right, and also along, yeah. Okay, yeah, so things are a little bit more complicated. Alright. Things are a touch bit complicated. Because the XY situation is just really, really complex. There's a lot going on in there, and I don't know if it'll be worth fixing. Like, I feel like most cases, yeah, the middle of the wall is like really, really jank. I don't know if I like that. Because I also feel like that is unavoidable, right? So because the only other thing that I can think of is no, that won't work. Maybe plus cell X plus cell Y. Um, not Y plus BID dot X, and then delete, right? I think this might actually almost, it almost completely and utterly solves the problem, right? Um, I think this also almost does it. All right. Um, so I can do um again almost. Close only counts in horseshoes and units. Yeah. Gotcha. Okay. So yeah, there's always gonna be interesting. B shift is equal to frac and B shift plus cell times 4 point cell dot y times 4 point plus BID dot y times some random set of numbers and okay. I think this is gonna look fine. Like, it doesn't look great, but it looks fine. You know, every other one is fine. I think technically speaking, it would be better if, yeah, I don't know. So, hmm. Right. Yeah, because I don't know. The left-right situation is kind of a pain in the ass. I don't know if I can easily decipher and discern that, you know? So, um, I don't know. I'm also gonna be right back. I gotta take care of something. Alright. Yeah, I mean, this is a really difficult problem. Right? Like, this is not a trivial situation. I know that there is a way to solve it. Right? Like, I know that I can solve it. Because I just need to figure out what, you know, because, like, if I could figure out, like, what plane I'm in, then I can decide the left and right, and effectively handle those situations. I think there is an argument that because, like, basically what I want to do is I want to extend the range of the cells into its neighbors, and then like build from there. I could do that. I think for right now it's fine, right? It is a little bit not super great for the most part. Like, it's more than serviceable, right? Like, it's serviceable enough. Like, I have variadic, you know, situations here, right? So here I have highly variadic bricks. And I think I like the highly variadic bricks. I'm going to keep the highly variadic bricks. And then just work on the cell boundaries later, right? The corners are still a little bit fucked. Times 8. So now we have exactly what we had before. Except now we have variadic bricks. We have, you know, a little bit of funky wonky fuckery bullshit going on. But I'm okay with that for now. Alright. I will be fixing all that up later. I have just these situations are fine, right? So I have that, like, crease right in there. I have that crease right in there. You know, these edges and stuff, right? Again, I don't really know exactly how I feel about these kinds of things with the edge, with the literal edge cases, right? It's Because it'd be kind of nice to do... What if I... Interesting. Might have a solution. Because there's like a boundary along the edge that, you know, you can detect on the edge of the cells, and you just don't put a thing there. Right? Like, you just can't do a thing. I will think about that. I'll think about what the ramifications are. Because I could do, I mean, I could also do like a snap situation. Like here, right? It's over there, it's over here. If it is on the boundary, I can make it so that it either snaps to one side or the other. Like, very strongly. Right? Or if it's like on the edge, I like don't deal with it or something. It's not, I will figure out something. Yeah, I will figure something out. Yeah. These are like mostly okay. Yeah, I mean, like, these are very, very chaotic and not very conducive to actual real-world masonry. So, I don't know. But having variadic bricks is super nice. Because I have the variadic, you know, floor pattern. I have, Because I don't know if I want to allow for, like, ultra wides in the center. Right there. Because if I were to get rid of those all together, then those could be really wide. Unless I... Shift. God, fuck, damn it. Where? Damn near problem solved. Damn near problem solved. So interesting. Well, that solved it. Which also means that I could do something a little bit more. Yeah, that should split things up just a little bit more so that we have a little bit more variation. And again, like, this is subtle. Alright, like, this is very subtle. Yeah, it's like here. We have that there, we have that there. So it's a very, very subtle variation. Interesting. I'll have to look into why this works so well. Right, it's like, I mean, it's like really, really subtle. It's very slight, but the variation is there. Right, like you can see that there's variation. It's not, every brick isn't exactly the same. Like on there, it's very, on here, it can be very, right? Yeah, it's just like shifting everything just slightly over and a bunch of other really cool shit, right? So that's cool. That's really nice. Might even be able to go up into here and delete that. And I think this is basically the same. Yeah. It's largely the same. There's like no difference. Which is okay. Alright. Yeah, it just flipped the diagonal that it lines up versus the one that doesn't. Right. So I mean, like, I'm okay with that. Technically speaking, I wouldn't necessarily want the short ones to be cut in like that, or at least not cut in as much. But I can't be bothered to figure out how to fix that. The outside might want different kinds of things, right? I don't really know. There's a lot of interesting things I can do with it. So this is pretty much good for you know, black and white. You know, I feel like not enough games do black and white aesthetics. You know, like this is very like ink and paper, you know, paper and ink kind of aesthetic. Very stark black white. So like that's something that we can do, that I can do. I don't know if I want to have, like, I don't know what other kinds of aesthetic I want to do. I also feel like I'm going to be wanting to San Francisco. I hardly know her. Yeah, the fact that I have procedurally generated floors, ceilings, both of those are unique. Everything about the walls are basically unique. Not entirely. Asterisk. And that's largely just because the two sides of the same wall are going to have the same pattern of bricks. I could go in and fix that as well, right? Because like this is that pattern, and then if we look over here, you'll see the exact same pattern, right? But I think it's like so subtle that I don't like it's not going to be as apparent as this, because you can't see both sides of the same wall, right? You can't see both sides of the same wall, so you can't really tell. Like it's not something you're going to notice. That and the actual deltas for these are so small that you will never see them. Right? Like it's very difficult to even tell that the bricks are different sizes. Right? Unless you're looking at the corners. So like that's, you know, something to keep in mind. I can fix the matching up, right? Because now the actual direction matters, and it's only within the X. So what I could do is actually do a vec 2 uv dot y times the, yeah, I think it's a uv dot y, uvt dot y times the sine of shit. Um, our dire dot what is it? Times the ray direction along the x-axis, right? And comma uvt dot z. And then here we do basically the same thing, right? Vec2 is uvt dot x times the sine of r dire dot y comma uvt dot z. Right, and then down here we get the color, two corner, da 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 da. And this is our right. Yeah, and this should fix, almost fix everything, except it did the opposites. So let's do times the negative of minus, just put one of them, it doesn't matter. Right. So now this is actually proper. Right. All of them are all properly matched up. All these are properly matched up, right? So now all of them are going to be completely separate. The actual, UV mapping is going to be completely different, depending on what side you're on, right? These corners look like a little bit funky, but that's fine, right? These are like very, very narrow bricks. They're not like the big chunky 2x1, 2x1x1s. These are 4x2x1s. Ish, asterisk. But there's some variation within, there's very slight variation within the actual widths of them. Because like that one's a thicker one. This, like, some of them are thinner, some of them are thicker, some of them are, this, that, the other thing. We still have the situation where one side is going to match the other. Oh, but it's going to be, ooh, okay. So now we don't have to worry about that anymore, because of the direction of the UVs are switched, right? So the actual sizes of the bricks are very different. It becomes even harder to tell that, I'm not doing it based on what side you're on. I think it's the pattern of the lines inside is gonna be like the same. But yeah, like who's actually gonna know, right? Who's actually? Yeah. So a 3D game with only one poly, only a quad. A 3D game in low 2D with only a single quad. That's what this game is. Yeah, this game doesn't. This does not have meshes. A game without meshes. There's no meshes here. This is a two-dimensional game. Yeah, like this game is 2D. This is a 2D game. Yeah. So I think the width of all that is Gucci. We have a really nice feeling distance fog. We have variadic textures. They're all completely procedurally generated. We have I mean, and also the like distribution in actual chaos, the actual chaotic nature of the hash function is like it's fun. Like it doesn't matter like at all. The only thing that's like really gonna matter is if I mean like I kind of want to do I mean I could do a few things, right? Because if for the static, right, doing the white noise, the static is going to be you know, like I'll keep adding the delta time to a counter, and then I'll just keep on wrapping that counter, right? That way, it becomes very, very easy to like that. That way, it stays chaotic for an extended period of time, and I can do some stuff with it. I wouldn't mind using the whatchamaface the golden noise, which is based off the golden ratio, which is very, 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 very chaotic. Well, it's not that it's very chaotic. It's that it's very irrational, right? It is highly irrational. It's the most irrational number. Like mathematically speaking, it is the most irrational number. The best approximations for phi are the worst for the longest. Like you approach phi incredibly slowly when you're doing rational approximations of phi. Whereas with pi, it is you can get very close very fast, right? With phi, with the golden ratio, there are no good approximations. You can get arbitrarily close, yes, but they're all bad. So, I don't know if I want to continue for much longer. I'm probably going to end up dipping out here pretty soon. And that's just because there's some other people that I want to spend time with, do stuff with. I have other things that I want to do, other things that I should do, things along those lines. But yeah, I have this, which is fucking incredible. Alright. Variadic bricks. I have variadic floor and ceiling. I have a really nice distance fog, view fog. The only other thing that I would need to do is have it's so good. Looks so good. Yeah. It's super solid. Yeah, hopefully next time we can stare at not a wall, right? Yeah, I think I'm done with the walls and floors. That should be good. Next it'll be, I mean, I want to do, I feel like I want to do the static next. But I am going to do it with a toggle. I'm also going to change the keybinds to be WASD rather than ESDF. I do ESDF because I'm typing a lot, so like my hands are just always at the home. You know, my hands are always on the home keys. So ESDF is just more optimal, more comfortable for me. Also, you have more access to more buttons more easily if you use ESDF rather than WASD. Hint, hint, nudge, nudge. Yeah. So, yeah, this is the end room for this one. Actually, I don't know. Ooh. Do I want to do... I feel like I should do a procedural levels or because there's the consumer, there's the void. Because I can do the void. I can do the static. I could do I mean, I could do that. Yeah, because like in the original, in the very first version that I did, when you reached a certain area, this all-encompassing void would start to spread and literally consume the rest of the map. And you would die. You'd take damage if your entire screen was black. You'd start taking damage. And detecting that is very difficult to do. Detecting when you have the screen is fully black is very, very difficult. You don't really have, because like you don't have easy access to the frame buffer, right? You just have, yeah. I'm gonna have to. And then there's other things that I might want to do with it too, right? Because I could say, because like the whole frame buffer as a thing, and I don't know if I have access to like atomic units that I can read from, right? So, because I could do. I'd have to like look into seeing if there's a way that I can effectively have like an atomic add, or like an atomic or an atomic and, that basically says, hey, if I do a 0, right? If I do false, atomic or whatever value of the current pixel in the frame buffer, then what ends up happening is that unit The entire frame buffer can operate on that one object simultaneously, and it doesn't matter because it's just bitwise or. I don't have access to bitwise or. Fuck. Oh, I don't think I have access to atomic operations in OpenGL 1.2. Shit. Oh, okay. Because the only other option is two options. I iterate over the whole thing. Or I do multiple steps. But doing multiple steps might be an issue because I don't know because I would have to I'd have to mandate that the window size is static. I'd have to set like a static window size and not allow people to like flatly disallow I would have to flatly disallow what is it called? I'd have to flatly disallow window resizing. Which I don't know if I like that. Right. A big part of games is the window size, and that is part of accessibility. So, like, your window size is part of the accessibility. For, like, a number of reasons, okay? So, I don't know. Things to think about. So, I think next will be... because, yeah, I have the textures done. I have the wall, floor textures. Those are done. I have 2D collision. I have distance fog. I have... what else? Because I also think that because there is, like, no true... darkness, right? Having actual true black is going to be terrifying. Yeah. I don't know, I'll think about it. I'll figure it out. Because I also want the void animation to be very specific as well. Because I don't know if I want the static, the white noise to be... Because I want the white noise to be a toggle. I don't necessarily know if I want to have a main menu, largely because, like, that's not really... it's like aesthetically, there's not really a big reason for me to want to have like an actual main menu and all that stuff, like options and things that should be, I feel like should be handled a little bit differently. Yeah, yeah, I don't know. And also, this whole thing here, alright? This inside corners, the inside corners, I don't know how I want to handle those. But yeah, no, I'm gonna end it here. I'm gonna be streaming again tonight in 9 hours. Yeah. Yeah. So yeah. Yeah, I'm gonna be streaming again tonight in 9 hours. I'm going to end it here. Hope you guys enjoyed. Hope you guys learned something. Hope you guys have a good rest of your day. Yeah. So let's do a git add, git commit, finished all textures, variadic brick or wall, variadic floor, and let's see. Doopy doopy doo. Doobie doobie doo. Dee 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 doo. Doobie doobie doo. Doobie doobie doo. Dee dee doobie doo. Doobie doobie doo. I don't know if I want to keep the blinking. I don't know if I want to keep. Yeah. Alright, that is gonna be all. Yeah.